Following the attempts of the last iteration of this software, as promised, this new iteration now features basic machine learning algorithms being incorporated in it. So, how it works now is that it uses a gradient descent function which accompanies its linear regression method to adjust the line to reduce prediction error with every single coordinate that is fed in. This, of course, is very dependent on how much data there is to train it. As someone who has worked in machine learning would know, more data may not necessarily constitute to a better model, as you risk overfitting and then being very unspecialized to unseen data pieces. So of course, validation error is something that should be taken into account here. Now, how does the new iteration compare with the previous? If we take a look at our improved menu, the top and GUI sections remain about the same. But what has really changed is in the compute section, where this code has been made redundant. A more efficient system has now been put into place where it takes into account the two scenarios that we have previously discussed and now aims to guess, using the gradient descent function, what the actual predicted y and actual y compare to each other as. What I mean by this will be explained very shortly. In the arithmetics class, the top part has also been made redundant. You can see here that we have now added a deep calculator. This is where the gradient descent happens, and in the example I'm showing there will be 1000 epochs. In layman's terms being the amount of times that we will loop through our training data. So, essentially we will look through all of our training data here in the unseen data.txt, or where I provided later. So it will be the amount of times that we will loop through the training data given and then repeating again. So if I have 50 pieces of training data, it will loop through the 50 and then do it again 1000 times in total. So it will do its predictions and then return the prediction here in a formatted way, which would then be presented to the user. The unseen data currently consists of 1, 2, 2, 4, 3, 6, and 4, 8 as coordinates. These are used to train, essentially, and probe where it is. You can see from my previous attempts an example of this, and I will get to that right now. The parser is the final step. The parser will read through the unseen data and then allow for the arithmetic and improved menu classes to access the data and loop through it. So let's get into it. Remember from the last video, the example equation I gave. We had the equation y is equal to minus 1.7x plus 0.7. And the points that we used were as xy, minus 1, 2, 0, 0, 2, 1, 3, minus 7. So, if we were to now go over here and feed in these exact points, let's say again, minus 1, 2, 0, 0, 2, 1, 3, minus 7, and compute this, we will get our estimation from the set of coordinates that we previously talked about, 1, 2, 2, 4, 3, 6, and finally 4, 8. Now, the actual y is 2, but we haven't given it the predicted y here. So the actual y that it's talking about is just the set of coordinates being inputted in, and it's not very relevant to this case. What we really care about is the 1, 0. So essentially it's saying we put minus 1.7 multiplied by 1 plus 0.7, and we compute that. For your information, this would be minus 1, of course. And what it's trying to do is it's trying to guess that value without just calculating it. It does that using the gradient descent function. Its guess was minus 1, 0.000 all the way to 1580, etc., which is pretty accurate. And if we were to take the other extreme of it and we put minus 1.7 times 4 plus 0.7 in, we're going to get minus 6.1, which is pretty close to minus 6.099999. So overall, it's a pretty good metric. With all decent works though, I like to concede and admit where it may fail. If I were to rerun the simulation, in its current iteration, due to a lack of refinement, it wouldn't be able to give very accurate descriptions of this curve should I just give it the first and the last point. So if I give it just minus 1, 2, and then 3, minus 7, as you would expect, this wouldn't exactly work as much as it would have with the other data points. So if I were to run the exact equation again, we will get drastically different values, with minus 2.5 being much further than minus 1, minus 4.75 being much further than it's expected, and minus 9.25 being further than what we just talked about. So overall, it's very reliant on the data still, and it needs further refinement before we can rely on its accuracy. If we are to continue refining it by adding more coordinates, let's say 0, 0, and computing, we will get minus 2.423076 and minus 9.231, which are also not very similar. So naturally, you'll be required to feed in a large majority of data. Now, this is only 4 pieces of data, to be fair, and I'm sure with a larger model, it would be more accurate should we give it 50 out of 60 pieces of data or 100 out of 150. So its accuracy would be dependent on data size too, and with such a small amount of data and relatively limited epochs, it would struggle to be very accurate unless given a surplus of information. I hope to refine this further, and I hope to change the valves a bit and see if I can get it to become more accurate. Maybe give it a larger training data set and try it with a very difficult model that I will calculate both by hand with the software's bottom 2 grids, and then finally by the machine itself and see how close it can get. But until I've warranted that it has indeed become a stronger model, I wouldn't do that yet. Thank you for watching, and I hope you found this video very interesting.